Today we're going over lesson 11.2 on the trapezoids, rhombuses, and kites area. Area of a trapezoid is the average of the top and bottom base times the height. Now this has also been written as is half height times base 1 plus base 2. It is also, again, how I explained it, height times base 1 plus base 2, all this part divided by 2. Just another way you could rewrite it, the same meaning. Now the other note here is trapezoid, right? We've got three important pieces, the bases and the height. Kite, the important pieces are the diagonals, and the same thing with the rhombus, the diagonals connecting opposite vertices, because those are involved in finding their areas on this slide. Fortunately, they're both the same. So if we run into a rhombus or a kite, even though they aren't related besides having four sides, the area is half diagonal 1 times diagonal 2. Find the area of the paint, which is a trapezoid, on the basketball court. In this case, we've got the paint that goes a little longer on the baseline than it does at the free throw line. And then we've got 6 meters and 3.6 meters for bases, and 5.8 meters is the height. Sometimes they will also give you the arrows to let you know that these are the bases, but at this point you can kind of clearly see the shape to see that these would be the parallel sides. So just plugging it in. Half times height, 5.8, times base 6 plus 3.6. And since it's decimal, I just plugged it into the calculator and got 27.84. We do have a label this time. We have meters. And since it's area, area is meters squared. Next problem. This rhombus represents an inlay in the guitar, and an inlay is a fancy word for if you have the guitar neck. I don't know if I'm going to bother drawing it here. Sometimes they'll have little rhombuses on that where the strings are covering it, right? So that's what they're talking about here. In this case, they say this little part is 9, this little part is 12, but it's not necessarily the whole, right? As a reminder, diagonals bisect each other, so these are equal and these are equal. And so this is not just the whole thing 12, the whole thing 9. This is going to be half 9 plus 9 to get diagonal 1 times 12 plus 12, which is diagonal 2, or 18 and 24. Doing the math, we get 216 millimeters squared. So again, it does help a lot to remember your formulas, half diagonal 1, diagonal 2, and then you just have to make sure if they didn't give us the whole diagonal, we need to add a second form of that, right? On this one, try on your own, now given these diagrams, to find the area. So the top one is a trapezoid, right? Technically, these right angles tell you that 4 is the height, and these are parallel, right? Consecutive interior angles add to 180, so these are parallel. And so we've got half 4 times 6 plus 8. So half of 4 is 2, 6 plus 8 is 14, 2 times 14, and I get area is 28 feet squared. Down here, we've got a kite, and notice they gave us the full diagonal this time. So we've got half 6 times 14, or 14 times 6, giving us 7 times 6 is 42 inches squared. Moving on, we've got find the area of the polygon. And now this time, again, they show you just this piece is 30, just this piece is 40, both for meters. Technically, we can figure out what the outsides are, but we don't need that. We just need diagonals. So this is 30, so is this piece. This is 40, so is this piece. So half of 30 plus 30 times 40 plus 40. Well, this is half 60 times 80, and so we get half of that is 2,400 meters squared, right? Half of 60 is 30. 30 times 80 is 24 with 2 zeros. Next, word problems. One diagonal of a kite is twice as long as the other diagonal. The area of the kite is 169 inches. What are the lengths of the diagonals? Right, so what's your area formula, right? Area is half diagonal 1 times diagonal 2, and it also helps to draw a picture. Right, so we've got a kite here. Diagonal 1 is this one, so diagonal 2 looks a little longer. We're going to call diagonal 2 is the one that equals 2 times diagonal 1. So now I have one variable. That's why we write it this way. So area equals half diagonal 1 times diagonal 2, and now substituting 169 for area, 2d1 for d2, and we've got half, 169 equals half d1 times 2d1. Well, 2 and half are going to cancel, so we're going to get d1 times d1 is d sub 1 squared equals 169, square root both sides. D sub 1 is 13 inches. Done, right? No, both diagonals. So now 2 times d sub 1 is diagonal 2, which is 26. 2 times 13 is 26. And again, we've got a label, so I added inches on there. Because they give us area, each like base, height, diagonal are all inches, meters, just 1 units. Okay. Moving on, we've got this picture that I kind of already have numbered off, but it says if each grid represents a 15 meters by 15 meters, find the area of the park drawn. And so we've got park as A, B, C, D, and it is a trapezoid. Right? BC, slope 0. AD, also slope 0. You can just kind of tell by looking. You could technically do the slope formula, but I'm just telling you by looking. And now each one of these moves is 15. Right? So what I'm doing is I'm just going to count. I've got 1, 2, 3, 4 is the base length up there. 1, 2, 3, 4, 5, 6, 7 is base AD, and then height 1, 2, 3, 4, 5. And now, yes, it's by 15, and I'm just going to plug 15 extra in for the height and the bases. So it looks like area equals half. Height is 5 times 15, because these are all 15s, times 7 times 15 plus 4 times 15, right? We're averaging the two heights, two bases, pardon me. And so when we calculate that, a lot of 5s gives us 6,187.5 meters squared. At this setup, it's definitely one you want to just plug in your calculator. On homework, I would like to see the work done that you get me to, here's my form, and then you plug it in on a calculator. So don't just leave me area is this, area is that. Seems too easy to copy if I just see a bunch of numbers for your answers. Last question here, we got the area of a kite is 216 feet squared. One diagonal is 3 times as long as the other. Find the diagonal length. So go ahead and try this one on your own. Now I recommend drawing a picture, so my picture this time, pretty similar, but it's 3D1, and sorry for the side length, how small they're getting. Area is half D1, D2, so now it's 216 is half D1 times 3D1, so this is going to be 3 over 2 D1 squared equals 216. But whenever I get a fraction like this, I like to just set it up as a proportion, and we're going to solve by moving everything to the left, because I have D1 squared right where I want it. I don't want that to multiply down. So multiplying 216 by 2, then divide by 3, I get exactly like this setup, and it's 144 is D1 squared. D sub 1 has to equal 12 then, right? Square root of 144 is 12. Plug it back in. What's 3 times 12? 36 is my other diagonal. Length is feet. Label is feet. And there is that. And that wraps up this lesson. Feel free to shoot me an email or any Google Classroom messages if you have questions. Thank you.